Hello class, this is Ms. Riggins and today we're going to be talking about trigonometry. And trigonometry is a topic of geometry that you actually have some experience with because it's involving right triangles with which we've been working with for the past week or so, and it also involves ratios, which we were working with last semester. So the only new math that you need to know is how they are related to one another. So let's see here, we have, as we can see, a right triangle. It has one angle, and as I move A, the point A, what do you notice about the triangle? If you say it's getting larger and smaller, you're absolutely right, but what's staying the same? If you said the angles, you're absolutely correct as well. So when I move A, the triangles that are produced are all similar to one another because the angles are staying the same, even though the side lengths are not staying the same. So that means that since all these triangles are going to be similar to one another, then that their corresponding side lengths are proportional, which means the ratio of the side lengths is the same. Corresponding ratios of the side lengths are the same. So let's take a look at this first ratio. We're going to call this ratio the sine ratio, and it's the opposite leg over the hypotenuse leg. Well, what does that mean? Well, based off this angle, which is theta, we're going to name it theta. That's the Greek letter, Greek alphabet letter. This angle theta has two sides that produce it, which is the hypotenuse and a leg. Well, this is the adjacent leg, but the ratio that we're looking at is the opposite leg, which is the 10.59, and the hypotenuse, and that's called the sine ratio, S-I-N-E, but we abbreviate it with S-I-N. So the sine of this angle is the ratio between the opposite leg and the hypotenuse. So as we can see, here it is, and that value of that ratio is 0.8912. Well, as I change the size of the triangle, it's still similar to one another, so the opposite leg over the hypotenuse leg, the values of these lengths change, but the ratio stays the same, which makes sense because all these triangles are similar to one another, which means their corresponding side lengths are proportional, which means this ratio should not change the value. The ratio is going to be the same. Let's take a look at another ratio. We've called it the cosine ratio, and the cosine ratio is with respect to the adjacent leg of the angle divided by the hypotenuse, as you can see here. And as we change the size of this triangle, the side lengths change, but the ratio for the cosine ratio, or abbreviated as COS, which we still say cosine, stays the same no matter what size the triangle is, because all these triangles are similar. So that's the cosine ratio, adjacent leg over hypotenuse. And then the next special ratio we want to look at is the tangent ratio. And the tangent ratio is just the ratio of the opposite leg over the hypotenuse. Over the adjacent leg, as we see here. So right now this ratio is 1.9646, and as I change the size of this triangle so that we still have similar triangles, the side lengths are changing, but the ratio for the tangent ratio is still the same based off this angle. So the important thing to know is that all these ratios will stay the same as long as these triangles are all similar to one another. So this ratio is based off of this angle, and this angle measures 63 degrees. So if I were to change the angle measurement, then these ratio values would change. So let's take a look at what happens if I were to change the angle measurement from 63 degrees to another degree. So let's see here. Now let's say I change it to 53 degrees. And as you can see here, the ratios for the sine, cosine, and tangent did change. But if I change the triangle so that the 53.8 degree angle still remains for theta, what happens is that the ratios will stay the same, but the side lengths will change as well. So, three important ratios for you to remember: sine, cosine, and tangent. And a little mnemonic way to remember which ratio, how the sine ratio is defined, cosine and tangent ratio is defined, is by the phrase SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent leg over hypotenuse. And tangent is opposite leg over adjacent leg, SOHCAHTOA. Now there are three other trigonometric ratios that you're going to look at a little bit more detailed in pre-calculus and later on, but these are the top three that you should hopefully memorize or at least know. That's what the sine ratio is, cosine, and tangent. All right, that's it. This is a short video, so let's have a good day.